Okay, exciting new project. I was wondering how you actually put an Android together. I kind of thought about it in terms of first principles, like I always do. Uh, these are some of the joint designs that I just sketched up real quick. Okay, here's a two for one. This is a two for one joint with the axis of rotation there. Same thing here, and this is something called a Z joint right here. And when you put it together, um, this looks like just a sketch, but inside of them is the actual joint layout. One of the things I'm especially proud of is most human beings figure that the rotation in their, the roll in their limbs is primarily centered around their joints. What I've done is I've broken it out into the center of the limb segment. Okay? And what that does is it allows you to bring in your motors or your artificial muscles or your electrical elastomers or whatever away from the joint in such a way that it simplifies the joint mechanics, so it's easier to design. Okay, here we have something. Let me see if I can get all of it in. Okay, uh, this is a leg for an android woman, and at this point it has foam board fairings or skin or whatever. But I want to show you how it works. Um, Basically, it's for measuring the angles in which it moves. Okay, so we have our carbon fiber here, and it comes down, and we have our knee joint here. And to show you how it works, let me just move it a little bit. Okay, see how it can move? Technically, it can move this way. We're thinking about limiting that in the control electronics if and when we ever build this thing. Okay, it comes down here. This is where we've broken out the Z joint. This is kind of an early iteration of Z joint, but it's basically PVC plastic with whittled dowel, and then it comes down here. This is the calf Z joint. This is the knee joint, and up here is where it connects to the hip assembly, where we have multiple degrees of freedom that implement what happens in the hip area. Okay?